Adding and subtracting fractions with unlike denominators. Adding or subtracting fractions with like denominators is pretty easy. You just add or subtract the numerators and keep the denominator the same. For example, if you have 1/4 plus 2/4, add 1 and 2 and keep 4 the same. The answer is 3/4. Subtraction works the same. If you have 3/5 minus 1/5, you subtract the numerators on the top and keep the denominator at 5. 3 minus 1 is 2, so the answer is 2/5. And you can mix addition and subtraction. For example, 1/3 plus 2/3 minus 1/3. On the bottom, the denominator remains 3, and on the top, for the numerators, you add 1 and 2, which is 3, and then subtract 1, which leaves 2. The final answer is 2/3. That's pretty straightforward. But what if the denominators are different? How do you add or subtract fractions with unlike denominators? What if you had something like 3/8 plus 1/4? Or 3/4 minus 1/3? How do we go about solving these kinds of problems? If only there was some way to make these fractions with different denominators have the same denominators. Well, there is. But before we get to that, let's consider what a denominator is. And let's make the problem a bit more real. To start figuring this out, let's get some wooden planks and cut them into equal segments. The first plank we won't cut. We'll leave it so we can see how long a whole uncut plank is. The next plank we'll cut into 2 sections. Each section is 1/2 of a whole plank. We'll keep doing this until we've added planks that are in thirds, quarters, fifths, sixths, sevenths, and eighths. Now, we'll put them aside and look at a fraction addition problem. 3/8 plus 1/4. We'll drag back our uncut board to remind us how long an uncut plank is and put it at the top. Let's grab 3 1/8 plank segments and 1/4 segment. And we'll line them all up. There's 3/8 plus a quarter. In order to add these fractions, we need to make all our denominators the same without changing the sizes of any of our plank segments. Let's look at 1/4. Let's try and make it a fraction with 8 in the denominator. We can see that 1/4 segment is the same as 2 of the 1/8 segments. So, let's pretend to cut the 1/4 plank segment in half. We'll show our virtual cut by drawing a dotted line. This makes our addition problem much easier. Instead of 3/8 plus 1/4, it's now 3/8 plus 2/8. We can just add the 2 numerators and keep the 8 in the denominator, which gives us 5/8. But what if it's not obvious how to make the denominator the same? For instance, if we're trying to add 2/3 and 1/5. One way to do this is a method that involves finding a common multiple of the 2 denominators. But what is a multiple? A multiple is a number that you get by multiplying a number by another number. 3 times 1 is 3, so 3 is a multiple of itself. 3 times 2 is 6, so 6 is a multiple of 3. We can keep going. 9, 12, and 15 are also multiples of 3. 18 and 21 are also multiples of 3. We could keep doing this forever, but let's stop here for now. So now we know what a multiple is. How do we use this to solve our problem? How does this help us virtually slice up our boards so that the 2 fractions have the same denominator? The process we are going to learn involves finding the smallest shared multiple of our 2 denominators. Or, as you may have heard in the phrase, the least common denominator of the 2 fractions in our problem. In this case, our denominators are 3 and 5. Well, we've already found a bunch of multiples of 3. 3, 6, 9, 12, 15, 18, 21, and so on. So now let's look at some multiples of 5. 5 times 1 is 5. No match with the multiples of 3 there. 5 times 2 is 10. Still no match. 5 times 3 is 15. Oh, ding, ding, ding. Yay, we've got a match. The smallest multiple that is common to both denominators is 15. The least common denominator of 3 and 5 is 15. So now we'll look at our planks again. Here's one plank uncut, virtually or otherwise. And here's a plank we virtually cut up into 15 segments. And here are our boards that are cut into thirds and fifths. For our fraction addition problem, we'll need 2 of the thirds and 1 of the fifths. Notice how both of our 1/3 board segments and the 1/5 board segment all line up evenly to the 1/15 board segment. This is because 15 is the lowest common multiple of both 3 and 5. Now, we can simply count up the 1/15 segments that add up to the same length as the 2/3 plus 1/5 segments and have our answer. 1, 2, 3, 4, 5. Wait a minute. All this board cutting counting is a lot of work. Now that we understand what's going on, surely there's an easier way of figuring out this kind of problem. And there is. Let's go back to our multiples. We want to change the denominators 3 and 5 into 15. And we want to do that without changing the size of our two fractions. Let's start by looking at the 2/3 fraction. We can see that each third is the same size as 5/15. So, 2 1/3 segments is going to be 10/15. But to get there without the boards and segment counting, we need to think about what's going on here mathematically. The number we are aiming for in the new denominator is 15, so we need to make that 3 into a 15. So what's a fraction we can multiply 2/3 by to get 10/15s? Let's start with the denominator. The easiest way to find a number to multiply 3 by to get 15 is to divide 15 by 3. This gives us 5. And for the numerator, what can we multiply the 2 by to get 10? 10 divided by 2 is 5. Hey, that's the same number we're multiplying in the denominator. And that will always be the case. If we think about it, this makes sense. Anytime you have a fraction where the numerator and the denominator are the same value, then the value of the whole fraction is 1. So we know that by multiplying 2/3 by 5/5, we aren't changing the value of the fractions. We are just making an equivalent fraction with proportionally different values in the numerator and denominator. Now we'll try this with the other fraction in the problem. We can see that 1/5 will end up being the same as 3/15. But let's hide the boards and the answer. We know the least common multiple is 15. So that's going to be the number in the denominator of the answer. To get the number we need to multiply by 5 to get 15, we divide 15 by 5. 5 goes into 15 3 times. So the number in the denominator of the fraction that we will be multiplying the original fraction by is 3. We put the same number, 3, into the numerator of the fraction we're multiplying the original fraction by. Remember that the new fraction is the same value as the one since its numerator and denominator are the same. Now, multiply the original fraction by the new one we've made. And there is our new equivalent fraction, 3/15. And when we bring back the boards and rearrange things, we see that we've got the right answer. Wow, I'm exhausted. I feel like I've been sawing wooden planks, both real and virtual, all day. Let's see if we can solve a problem without sawing. Here's a new problem, 5/6 plus 3/4. To start, we need to find the least common denominator of 6 and 4. The first few multiples of 6 are 6, 12, 18, and 24. The first few multiples of 4 are 4, 8, and bingo, 12. The least common denominator of 4 and 6 is 12. For the first fraction, in order to change the 6 into 12, we multiply it by 2. 12 divided by 6 is 2. To keep the size of the fraction the same, we multiply the numerator by 2 also. So 5/6 can be written as 10/12. For the second fraction, we need to multiply the denominator of 4 by 3 to get 12. Again, we multiply both the denominator and the numerator by 3 and get 9/12. Now that the two fractions have a common denominator, we can just add the numerators. 10 plus 9 is 19. The answer is 19/12. There's our answer. And not a board or handsaw in sight. Since the numerator is bigger than the denominator, we simplify this fraction to the mixed number of 1 and 7/12. Oh yeah, and subtraction works the same way. Only you subtract the two numerators instead of adding them.